Hello everyone, welcome back to the channel. In today's fourth video on this channel, I'm looking to talk to you about the Jupyter AI. This is an open source extension to Jupyter Lab that you can utilize to supercharge your development. So if you have any questions, if you need help thinking through the use case that you have in hand, and you need some help with generating code to implement your ideas, you can use Jupyter AI at no additional cost, embedded directly within the Jupyter environment. So this is going to be a chat experience, like what we can see here on the left-hand side, and this is what we're looking to set up. So there's no cost of utilizing this. The only cost that we will have if we set this up is a cost from the model providers, whether they're OpenAI, Anthropic, AI21 Labs, if you have models on AWS with Bedrock and SageMaker and so on. So this is going to be a pretty interesting overview of how we set this up, how we use it, and then if you're interested in diving deeper into the generative AI, I'll share some good learning plans. They're entirely free for you folks to explore. If you folks enjoy these videos, if you like these types of walkthroughs, if this is providing value to you, please consider liking and subscribing to let me know that is the case. You can also drop some of the comments if you have any thoughts or if there's something in particular that you would like me to make a video on in the future. So without further ado, let's jump into today's discussion. So as we can see here, this is the chat experience that we're looking to set up. And what's immediately, as soon as this crossed my line of vision, immediately what I thought about was, okay, which models can I use with this? And this page in the documentation from Jupyter community, and I will share this include this in the description of the video, so you folks can review all the references and read up more on the things. They actually do a good job at providing the list of model providers right here that gives us a clear understanding of just what types of model providers and models can we utilize through this solution. And we can see that a variety of AI startups are supported, like AI21 Labs, Anthropic, and so on and so forth. OpenAI is there, including Gemini as well. And what we're interested for today's purposes, today's discussion, is how we can use models from AWS with this extension. So we can see that there's support for Bedrock, as well as if you scroll all the way down, you can actually deploy your own models or models from SageMaker Jumpstart onto SageMaker endpoints and then just provide that SageMaker endpoint ARN, or Amazon Resource Name, the unique identifier for your endpoint, which will allow this chat interface to start sending inference requests to that endpoint where you're hosting whatever you have. You can train your own large language model, deploy it on a SageMaker endpoint, and then use it through this chat interface. Now, what's the easiest way to have this set up? I would say through SageMaker Studio. SageMaker makes it very, very easy to set this up because it doesn't require us to run any code. It just requires us to select a particular type of a distribution image, as we will see here shortly. So there is a little bit of a snippet on a discussion here on the Jupyter AI on the AWS, in the AWS documentation as well. I will include that for you folks, but you can see the key requirement here is that we utilize the SageMaker distribution version 1.2 or above. And anytime you create a Jupyter Lab space in SageMaker Studio, you're asked to provide the image that should be used to set up that space. So for as long as we select one of the latest images, as long as it's greater than 1.2, Jupyter AI will come pre-installed, pre-configured for us to utilize there. And there's going to be a walkthrough of how this can be installed, the installation. Here, again, we just need to make sure we use the SageMaker distribution image 1.2 or later, and that's it. There's no further code, builds, construction, nothing. It's all set up. It's going to come with it. And there's also a nice walkthrough of some of the features of Jupyter AI. They can be used as a supplemental reading for what the Jupyter community provides as well. So on this page on Access Features, you'll find what you can do with this. So I think the best way to figure out what you can do with this is for us to see how we can use it. So to do that, I'm going to navigate to my SageMaker Studio environment, and I've set this up as IAM and Identity Center application that my user can have access to. So that way I don't have to go through my AWS account at all. I can just go into SageMaker Studio application here, which will take me directly there. If you folks are interested in learning a little bit more about IAM Identity Center and SageMaker, how you can integrate it too, which is what many AWS customers do because they want to implement a single sign-on capability and not have to maintain duplicate identities on AWS. If that's something that interests you, just let me know in the comments and I can make another video to walk you through how you can set up how you can set up a single sign-on. So you practically can have a single sign-on page where the user signs in and they have a list of all the AWS accounts and a list of all the applications like SageMaker Studio that they can easily access. So once we're in SageMaker Studio, I'm going to navigate to Jupyter Lab, and this is where I have various Jupyter Lab spaces. I'm going to go ahead and create a new space. I'm going to create it, let's just call it new space here just to keep it simple, and I'm going to say create. Now, as soon as this instantiates, it's going to allow me to configure this space with things like instance type. So let's maybe keep MLM5 2 extra large. That's going to give us 8 virtual CPUs in 32 gigs. That's going to be plenty there. When it comes to the image, remember, we need to make sure we're running at least SageMaker Distributed 1.2, version 1.2 or above. So this is the latest version, 2.30. That's going to be plenty. It's going to work just fine for us. I'm also going to include a little bit more storage. Instead of just 5 gigs, I'm going to say, let's do maybe 30 gigs, and that's not 530, that's 30. You need to have at least 5. That's why that 5 was there. So idle shutdown, I'm going to keep that to 60 minutes. That is going to practically ensure that if you just get up and walk away from your desk, in this case in 60 minutes, this space, Jupyter Lab space, is automatically going to shut itself down. So you're not incurring any charges. In the past, years ago, when we used SageMaker notebooks, we had to create our own lifecycle policies that get attached to those notebooks and that run our own logic to identify if the kernels are idle. If they are, shut them down. You don't have to do any of that anymore. Within SageMaker Studio, this functionality is built in. It's going to be able to identify if the space is idle, and it's going to go through the process of shutting it down after predefined amount of time. Now at this point in time, I've skipped any lifecycle configurations and I selected run space to get it to start up. Lifecycle configurations can be pretty useful to automate some of the setup for the space. So there's a variety of, for instance, Jupyter extensions that are pretty useful when you worked in Jupyter environment. For instance, there's one from IBM that allows you to view any data in S3 as if it was a local file system, just to kind of provide a nice UI so you don't have to only programmatically interact with S3. Things like that you can automate setting up through lifecycle configurations. In our case, we don't have to do it here for JupyterAI because, again, it comes included with the SageMaker distributed image there. Now we can see that this space is available now. It's already running, and I can just say open Jupyter Lab to access it. Now with this, when this loads up, you will see a standard Jupyter Lab environment. I'm going to zoom in a little bit so you folks can see a little bit easier. And what you're going to notice on the left side is this little chat icon near the bottom, and that is where you'll find JupyterAI. So if we open that up, you get a little bit of a preview of what you can do with it. Now by default, the LLM that's going to be used, or the model provider, is going to be Amazon Q Developer. That's practically, because we're running this from within SageMaker Studio, you could use Amazon Q Developer, it's great, but you can also change it to some of the other providers. Now, for the purposes of this walkthrough, let's change it so we can see how we can change that. You click that gear icon in the corner, and this is where you can select the completion model. So you can see Q Developer is pre-selected, but let's select one of the models from Amazon Bedrock. So you can see there's a host of Anthropic models, and I'm going to select this Claude 3.5 Sonnet version 1 as an example that was released, you can see here in June of 2024. So let's select that because that is available through on-demand prompting. You don't have to purchase the provision throughput. For some of the other models, you may need to do that. So I'm selecting this one as a very capable model that is very easy to use, and it doesn't require us to purchase any provision throughput. We can just interact with it on demand. So that's going to be completion model. What is this embedding model? So it's pre-selected to none, but you can potentially select an embedding model for some types of completion models. And Anthropic's Claude 3.5 Sonnet supports this. So what does this allow you to do? It allows you to take some of the content, as you'll see here shortly with what I'll show you, and generate embeddings out of it, and then very efficiently do semantic search against that content. So let's take a look at an example here. I'm going to choose, let's choose Titan Embed Text v2 as the model. I'm going to say save changes here. So let's go back and let's clear this because we're not using Amazon Q Developer anymore. So you can see Jupyter play on astronaut word combined with Jupyter is basically JupyterAI here, and it shows you some of the things that we can do with it. For instance, you can ask JupyterAI to learn information from some of the local documents here available in the Jupyter environment, and you can run /ask and ask it some questions about that. You can also ask it to just generate a whole Jupyter notebook based on your requirements and optimize code, fix code, and various other things, refactor and so on. So let's take a look at how we can use that embedding model that we just discussed. So what I'm going to do here is let's maybe go to a well-architected framework page, and let's get some of the best practices in terms of working with the ML workloads from there, as AWS guidance suggests. So well-architected framework is very holistic. It covers practically building anything on AWS, following best practices, and it comes with these 6 different domains or 6 different pillars like security, reliability, performance efficiency, and so on. I'm actually going to go straight to the best practices for machine learning workloads, and we can find that through these lenses. So these lenses are highly specialized components of well-architected framework. You can imagine taking the best practices, but then showing them, representing them from the particular either industry or technology perspective. So you can see there's a machine learning lens available, and there's a PDF version of it as well. So let's grab the PDF, and I'm going to go ahead and save that PDF. We can see there's 195 pages there in total. So let's go ahead and save this locally so I can then take it into my environment. I'm going to add a new folder, and I'm just going to name it JupyterAI here so we can just save things directly there. Okay, so this is saved now, and what we need to do is we need to upload this practically into our Jupyter environment. So I'm going to go ahead and grab that for us here. So I'm going to take my local file system, that JupyterAI folder I just created, and I'm going to actually rename this. Doesn't need to be called one. This is a copy from an earlier review, and I'm going to just drag and drop this to upload it. So this has been uploaded, the whole almost 200 pages of best practices of working with ML workloads on AWS. And now I'm going to go back to JupyterAI, and I'm going to say /learn, and I'm going to provide the asterisk. That's going to tell it, hey, learn anything that is within the root path, not from specific document, but from anything. Now, I could have just specified that document, but you can imagine there could be many, many documents included here, and you just want JupyterAI to absorb this entire content. Now it's complaining here, it's saying in order to run this learn, which right now it failed, we need to have this PyPDF package installed. So let's go ahead and do that. That apparently does not come pre-installed with this image. So I'm going to open up a terminal here, and I'm going to just paste that command to install the PyPDF. So that's been set up, that's all ready for us. So let's run the learn command again. I'm going to do learn asterisk. And you can see it tells us right now it's in the process of loading and splitting files that it was able to find within this local directory. So that's the directory that we're currently in. If I go into the terminal, type pwd to show the local directory that we're currently in, you can see it's the same directory, home, SageMaker user, which is typically which is very common for using SageMaker Studio. So practically what JupyterAI is doing now is searching for any documents that are within that path, and it's going to be splitting them into smaller chunks, and then using the embedding model that we selected, which we selected the embedding model from Titan embedding v2 is going to generate the embeddings, and is going to store those embeddings in the local memory store, local vector store that's running within the notebook itself. It's FASS, FAISS, in-memory vector store that was released by Meta there. So that's practically what this is pre-configured as to use as a vector store. So it was able to learn the documents from this path, and it's ready to answer any questions from us. So to do that, we can just type in /ask and then type out our question there. So let's try it and let's see how it works. So I'm going to say ask and then I'm going to say how can I ensure, or maybe we should ask what security best practices. So what security best practices should I follow when deploying my ML model? So let's say you're new to this, you haven't worked with SageMaker as much, and you're just asking a question here to try and understand, okay, what are these best practices? Of course, you could go into the ML lens and read up on things, but hey, maybe you're short on time. Maybe you are in a crunch. You need to get this project done quicker. And this is why I see this tool as an accelerator. Right? Allows you to move much faster and spend less time kind of cycling through the documentation. So it was using, we can see here the response, it was practically using the details from that ML lens to generate a response to our question. So it's saying, based on information provided in the context, what is in the context, that ML lens that we ask it to learn. Here are some key security best practices to follow when deploying the ML model. You should restrict access to intended legitimate consumers, or in other words, follow the least privileged access. You should secure the inference endpoints, and it tells you exactly how to do this. You should monitor the model interactions, validate data permissions and privacy, design data encryption and obfuscation, review software licenses, agreements, and so on and so forth. And these bullets and the information here comes directly regurgitated, rephrased, summarized, if you will, from that ML lens that we used earlier. And you can just chat away. You can ask it any questions, and then as you're building your own solution, you can make sure that you follow the best practices without having to read the 200-page ML lens yourself and memorize everything from it. So we saw here how we can practically do the RAG, retrieval augmented generation, very, very quickly, very, very easily using the JupyterAI. Now, what I would like to do next is maybe see how we can accelerate the work on a project. Work on the ML project, the data science project, using this convenient little tool. So what I'm going to do here is I'm going to clear the chat because we're not going to be continuing discussion along this topic. Instead, what I want to do is I want to take this diabetic data set from Kaggle, which you can download it, available for anyone to access. And I want to use JupyterAI to guide me to do exploratory data analysis, understand the data, if there's any data quality issues, and then guide me through how I can train the model on SageMaker to predict the target variable from the data set, do hyperparameter tuning, and do deployment as well. So let's see how we can do that. Let's select here on Kaggle page, download. And again, don't worry, I'll include the links for everything I'm walking through here for you folks to easily access. So I'm going to say there's a few different ways to access it. We can just download it. For the purposes here, let's just use the programmatic approach. And there's a Kaggle Hub library that we can use to access a variety of data sets available there. So let's maybe go ahead and do that. It'll be more interesting than just downloading and uploading a file. And I'm going to open up a Jupyter notebook here so I can paste that code that we've selected. So this is going to import the Kaggle Hub, and then it's going to download the data set, let us know along which path it is. So let's go ahead and run this. All right, it's complaining again, and it says no module Kaggle Hub. Great opportunity to see how JupyterAI can help us fix this. So let's go ahead, let's go back to JupyterAI, and let's type in fix, and we're going to just run this. Now, how does it know what the context is? Whenever you use fix command, it's going to select practically pull in the selected cell from the Jupyter notebook. So you can see the cell is selected. So along with my question or along with my prompt fix, it's also going to pull in the error and the cell in question as the additional context. And if we scroll further down, it's going to say, it looks like the Kaggle Hub model is not installed in your Jupyter Lab environment. To fix this issue, you need to install Kaggle Hub. And it's going to kind of suggest this little snippet here, which you can run it without the exclamation point in a terminal, or if you include exclamation point, it's just a convenient way to run this directly within your Jupyter notebook. And what we can do here is I can keep this, I can select the cell, and I can choose the swap option. So this is going to replace what the JupyterAI suggested with it's going to replace the existing issue that has an error with the updated code. So we replace that, and I'm going to run that cell again. It proceeds with installing that package, and then it's going to start running that code to download the data set and make it available. So you can see extracting files, a path to dataset files. So this is the path where the data set was downloaded. So let's go ahead back to the terminal and just confirm there is something in there. I'm going to type in ls, that path, because it's a folder, I'm going to add a /. And indeed, we see that this diabetic_data.csv file is available there. So let's go ahead and copy it to our current working directory, so I don't have to reference this really long path here. So what I'm going to do here is I'm going to do move command. I'm going to include this entire path here, and I'm going to add the name and paste that, and I'm going to say let's move it to the current directory. So this has been moved here, which means I should be able to see it right here, and there it is, diabetic_data.csv file. So what we want to do next is I want JupyterAI to help guide me through understanding the data set or performing what we call exploratory data analysis, and then going through the process of guiding me of training a model and hyperparameter tuning it and then deploying it on SageMaker. Let's say I'm new to SageMaker and I need a little bit of a help there. Let's just, before we do that, let's open the file and see what the data looks like here in this CSV file. So we can see we have a variety of columns, a variety of features, and this data set is, if you read up a little bit on Kaggle, what it represents is practically practically represents the data about different patients. And the goal here is to try and see if the patients had to be readmitted to the hospital after they were released. See, that is very problematic, can be very costly for hospitals to release a patient and then the patient needs to come back. It is oftentimes much better for them to just keep the patient until they no longer are going to need the care than having to release them, readmit them, release them, readmit them, and that can really mess with the capacity planning for hospitals. So here near the end, the last column is going to be the target variable. You can see here, readmitted is the column here. So that is going to be the target variable, and that is something that we want to train a model to be able to predict. And here you may wonder, okay, why not just use one of these LLMs to do this type of classification modeling? And the answer is that you can just have a simpler classifier that's going to be much lower cost to run. It's going to have much lower latency instead of running something that is much greater, much more powerful than what's actually needed to solve the problem. So if you have these types of ML problems that you're faced with, you're going to go back to just building out your own smaller classifier that is very low cost and very, very fast without having to rely on the LLMs. So readmitted is our column of interest. So let's now proceed and let's go back. I'm going to go back here and let me maybe remove this. We're not going to need this anymore. And let's go to the chat. Let's clear it so I don't have to continue the discussion here. And I'm going to now say, I have, let's see, I have, and what's the name of the file? Diabetic_data CSV. So I have diabetic data CSV file that contains information about patients and whether they were readmitted to the hospital. I would like you to generate code to accomplish following. And let's give it some requirements. So what do we want to do? We want to perform exploratory data analysis to understand the data and any data quality issues that need to be fixed. Then next, we want to train a classifier to be able to predict readmitted column. And we specifically want to, this is where you want to be clear exactly what it is that you're looking to do. So train classifier to be able to predict a readmitted column, and say train classifier on SageMaker. SageMaker to be able to predict the readmitted column. Then we're going to say perform hyperparameter tuning on the model. And finally, deploy a model to SageMaker endpoint. Let's say that. And when it comes to performing hyperparameter tuning of the model, I'm going to say with SageMaker, just to make it clear, right? You don't want to leave any room for assumptions for these models. You want to be as clear, as specific as you can in terms of what it is that you would like to accomplish. So let's run this. We gave it plenty of work to go and think about. And let's see, what does it say? So it says, certainly happy to help you with generating codes. And it's going to start with the exploratory data analysis here first. That was our first requirement. So it includes, and it keeps generating a response. It's going to be a pretty long one, which is why it just keeps moving up. But you can see this first section is going to be focused on the exploratory data analysis. So let's do that swap cell function here to insert it into our Jupyter notebook. And we can see here it is importing various libraries like pandas, visualization libraries like Matplotlib, Seaborn, computation library like NumPy, and then it's going to load that into a pandas data frame and generate various information around a number of features, data types, missing values, and also generate some of the visualizations here for us as well. Some histograms, heat maps, and so on. So let's run this and see what we get. I'm going to just close this so we can see temporarily what it is that it's generating here. And you can see the output here contains a variety of information about different features that we have, the non-null values, your typical describe on a data frame. And it's going to include various statistical information for each of the features around what is the mean or average, standard deviation, minimum 25th, 50th, 75th percentile, maximum values. It's going to generate that for, or not generate, but it's going to run code that's going to show us those statistical properties for different features. It's also going to generate some bar plots here, which is going to be pretty interesting for us to see the readmitted column. So it looks like we have the most patients here have not been readmitted. So the over 50,000 patients that we have in our data set have not been readmitted. And then some have been readmitted after 30 days or in under or less than 30 days. That's the minority. And it's going to include the heat map as well to show the correlation coefficients and their strength between the different features and so on and so forth, right? A bunch of different visualizations that can be pretty useful, pretty handy for exploratory data analysis. Okay, let's go back here, see what did it say next. So second requirement we gave it was to train a classifier on SageMaker. And it says, why not use XGBoost, extreme gradient boosting algorithm? It's a pretty good fit for classifiers. In fact, it's one of the most popular algorithms there. So let's go ahead and just replace the next cell with this. And it's going to import, again, let's just hide this. It's going to import the SageMaker SDK. It's going to use the XGBoost, and it's going to use scikit-learn library to do the splits for training, validation, and test data sets. So with that, it's going to, looks like it's going to drop the readmitted column because that is going to only be a part of the label, and then it's going to go through a process of splitting the data set into the training and test data set there. And then it's going to proceed with uploading data to S3 and then also running the training job here for us. Now, one thing that just eyeballing here that I think may run into an issue with is that it seems to be utilizing some entry point here, which we don't have there. So what potentially may have happened here, just looking at this, is that we've hit the maximum response there. So with maximum response, which you can adjust with these models using the environment variables, our output practically has been truncated. So this is not going to be the end, but it's going to be truncated, so that's why it kind of looks like it just stops there, right? There's nothing beyond. So to bypass this now real quick, we can just say, we can split the requirements into individual requirements. And we can say, let's do this. Show me just the code to perform the following on that diabetic data CSV data set. Perhaps I shouldn't have included so many requirements as part of a single prompt, but it's okay. We're going to say, show me just the code to perform the following for that diabetic data set. Now it should be able to show us the entire data set that it had in mind. So we can see this is the entire data set, and it looks like it proceeds with performing the deployment here right after as well. So we can insert this. So let's do replace that. And then it's also going to see, because here it's referencing the entry point script, and that's the part that was truncated previously. So it's referencing this entry point script, which doesn't exist. So after that, it's going to give us the contents of this script. So it's going to say now that you'll need to create a file named this and include the following code in it. So let's go ahead and copy that, and let's say XGBoost underscore script. So let's do new text file. I'm going to paste the code there, and then we want to rename that file to make sure that that's going to be aligned with what's expected. So let's save it to have that name, rename. Okay, so this is our script, and I'm going to X out of that, and let's run this next cell. In fact, I'm going to just comment out the deploy part because I don't want to deploy the SageMaker endpoint just yet. So I'm going to run this, and let's see, it's complaining with the XGBoost not closing, so that should be fine here, because we do close unless there's a missing parentheses. And again, the point of these systems is they're not perfect, so they're not necessarily going to solve all your problems. They're just accelerators. Okay, it looks like there's something off with the closing brackets, which I can see here that we are closing it. So let's run again. Okay, so let me do this. Maybe it's the matter of the indentation here. So let's run this. Okay, so this was never closed. I do see that it's closed here, so I'm not able to see right now why this is not running. But let's do this. Let's remove this from the cell so we can run that previous cell. Oh, I see. So okay, so I understand. So this is what he's complaining about. So when I replaced the cell, I've practically just copied the content, because this little thing here is going to replace the selection. I haven't selected anything other than just the last line of the cell, so it didn't replace anything, just concatenated what it previously had. So let's easily fix this. And so there's nothing there. I'm going to say replace now. And sorry, this is the wrong cell here. That's our Python script. So this is the cell that we want to include. So now we're just have the complete response without the previous response that was truncated there. So let's go ahead, and I'm gonna just comment out the deployment steps so we can just run training for now. And I'm going to run that cell. And we can see here, if we scroll further down, what we should be able to see is the little hyphens are going to start ticking. And that practically reflects the deployment, the loading bar that SageMaker typically has. If we also go to SageMaker in the console, so let me just sign in here, and we should be able to see a SageMaker Training Job running as well. So let's take a look at that right here. And this is my personal account. So I'm going to go to SageMaker AI service, and let's go to training jobs. So let's see if there's a training job that's running there. So let's go to training section, training job. And we can see there is a training job that is running right here. It's currently in progress, and it's downloading that data set, the splits from S3. And then as it continues running, we're practically going to be able to track all the information around what are the inputs, what are the outputs, what the training image, container image was used. So we're using XGBoost 1.5 container image. We get to see the EC2 instance type, MLM5 extra large, one of those. If we take a look at the code, that's going to be exactly what we use. One of those, MLM5 extra large. So what's nice about this is that you practically are focusing just on development, and JupyterAI is helping you with that. And then as you are running different workloads, SageMaker AI is going to be tracking everything that is going on there. So there you go. We don't have to wait for the rest of this. You can, on your own, go through the remaining process of, if you want to do hyperparameter tuning, you can do that. If you want to deploy the model to a SageMaker endpoint, there was already code for that I commented out here, because I don't want to have to go through the process of deleting everything and forget that I've deployed something, where you can just see SageMaker Training Job here. So there you go. We went through the process of talking about what is JupyterAI. We talked about how you can easily set it up in your Jupyter environment in SageMaker Studio. Just a reminder, there's no setup other than choosing a particular container image that should be used with SageMaker Studio. And then we went through the process of seeing how RAG works with the asking JupyterAI to learn and retrieve the information from the documents. We saw how we can fix errors, ask it to troubleshoot, as well as how we can share our requirements, and then have JupyterAI generate code for the implementation there. Now, if you're looking to dive deeper into this space, the two learning plans, or I should say two learning objects I would recommend to explore is, first one is this learning plan, the Artificial Intelligence Practitioner Learning Plan. It comes with various courses. You can see it's free. It's not going to cost you anything. And it's going to walk you through the process of the foundations of ML and AI, all the way through talking about the relevant details around how you develop ML solutions, how to work with generative AI, how to optimize foundation models through prompt engineering, RAG, fine-tuning, continued pre-training, some focus on security, and prompt engineering best practices as well. Aside from this is going to keep you entertained for quite a long time. It's going to take you about 8 hours to get through everything here. If you want to take a step further, you can also play this game. It's available for free, Card Clash. It includes Generative AI Island, and practically it's a card game that teaches you about different architectures and how to construct different GenAI solutions using what services and how they all get integrated together. So if you are an architect and one of your core functions are to understand how these different services come together to construct a bigger solution, this could be an interesting and fun, low mental load way to just kind of kick back, relax, and learn a little bit more there. If you're interested in learning about the best practices from that framework that we used JupyterAI to analyze, there's a learning badge that you can also get by completing a free course and get well-architected best practices learning badge, similar to the certification badge, except that this one would be still awarded by Creedly and provided to you within 5 to 7 days upon the completion. So if that's something that interests you, I'll include the link there as well. So hopefully you found this interesting. Let me know if you are using JupyterAI, how are you using it, if you ran into some of the issues like we did here during the demos. If you found, fortunately we were able to solve all the issues, but maybe you ran into some issues that you were not able to solve, you can just let me know what they are. Give the rest of us a heads up there. And hopefully you enjoy this. I'll catch you in the next video.